Okay, hi everybody. Tuesday, 11th of May, and we're talking today about the Mur Ligases. And let me share screen so we've all got the same thing in front of us. That might just be the easiest thing to do, right? Is that the right window? Hopefully everyone can see that. Okie doke. So, I mean, it might just be easiest to whip through some of the things we spoke about last time. So the actions from last time, which will probably bring up everything we want to talk about, actually. So Yuhang, you have been pursuing synthesis of the AZ compound that we need for, maybe further study, and having some issues with an isomer being made, and has got ideas about how to beat that, and has been acting on some suggestions from Joe. Yuhang, did you want to say anything? I mean, it's all in the update you provided on the GitHub post, which is awesome. Do you want to say anything about that?
Do I need to go through it briefly, or? I mean, it's fine.
Yeah, if you want to, just in 30 seconds.
Yeah. Okay. Sure. That's a lot of pressure. All right. So this week, this month, I explored 3 different temperature scales to trying to get the blue ideal product, which is a typical interaction core for the AZ compound. And what I've been trying to do is to use the base in the solvent to generate the methyl hydrogen in situ, so that I could preferably get this blue product, but the results didn't show well. So I think the justification procedure, we can just jump.
I mean, you think you're making this thing?
Yeah, I think I made this. Yeah.
Which is the isomer, and so you're trying to prove that by making this urea, crystallizing it and proving it.
Yeah, exactly.
Yeah, cool. And then I think you've been also investigating other potential ways of making the right compounds.
Yeah. So I'm not quite sure about the first line of the next step, which is the reaction I've been doing. I finished today. WYH. All right. Yeah. This guy is from Joe. So I decided to do this as soon as the starting material arrived.
So this is coming in pretty soon.
Yeah, exactly, this week.
Great. And this should be a neat and this gives us a compound which is active, which is great.
Yeah. So I have a question about the reaction. Could you please scroll up a bit? Then yeah. So the first reaction, the next step. So I changed the solvent system. I decided, but this is not public. This is not referenced. It's just the solvent system taken from the reference, but with different starting materials. So I'm not quite sure if this will work or not. But the essential idea was to generate the methyl hydrogen in situ. That's what I want to do, and I think this condition is a bit useful because it forms salts, and it will get isolated from the system. Yeah, that's all I got. So I don't know if anyone got suggestions. Please tell. Yeah.
So this is Joe. So I guess, I mean, valiant efforts here. I don't know, obviously I'm not a synthetic chemist, so I can't help you on that aspect of it. But, one of the things I think, I guess my recommendation, I'm not trying, really is to move on to trying to make the isopropyl, the one at the bottom. It's commercially available. You said it's coming in this week. And something to think about just in terms of, one of your goals, or one of the goals of the project, was to hopefully try to bring in some more wild type gram-negative activity. So I don't remember what the actual MIC of the compound on the right is, the isopropyl version, but mean, one of the things here you would get would be, once if you made the amine of this analog with the isopropyl pyrazole, in theory, you should have even more of a, I'm going to call it a delta, more of a shift in the actual MIC to test your hypothesis that adding a basic amine would actually improve the MIC. So just from I don't know, I think from an efficiency and time point, I'm not sure I would pursue the top too much more, and really kind of see if you can generate, the isopropyl analogs and then move on to trying to make the amino version of that. I mean, that would be my recommendation at this point.
Yeah, I think we're caught here in the usual tension between prosecuting a MedChem campaign and doing things which are good for a PhD. So in this case, the reaction's been done, and we need to do a few things just to prove which isomer we've got as an academic exercise. But you're right, this compound and the amine analog are what we actually want. Functionally is what we want.
From the crystallography, I think the reason why we want to all right, yeah. So no worries. I misunderstood something.
Great. All right, thanks. So hopefully, compounds will be made by, I guess by the next meeting, we should be having these, I think, the way you're going, Yuhang, and obviously when we've got those, we can distribute them around to anyone who wants them. And then we'll get on with making analogous compounds. But we wanted to get, ideally an active, an inactive, and an experimental would be great. So, this compound plus something that's inactive, maybe as a control, plus the amine. Definitely those are the targets, yeah. All right, awesome. Thanks for that. And then update on the shipping of the atomized compounds is that we have bifurcating multiplying paperwork. So there's MTAs now have been sent from UCL to Warwick and Diamond, and those are being investigated by those institutions before, and that would constitute an agreement, which we can then say to, and then we can say to Atomize, we formed an agreement, everyone's happy, we can go ahead. So the paperwork is at least happening, and it's being digested. I don't have much more an update to say than that, nor the will to talk about it much more.
Great.
So this is moot now, because we're not going to ship directly to Diamond, because Diamond turns out, I think, also maybe would like, well, no, Diamond are happy to engage in the need for ECL to have an MTA. So we're going to go with that route. All right, next thing was Becca to complete screening of Lizbe SGC fragments, current screening of dentically collaborated fragments. Does anyone involved in that want to update us?
Yeah, so the screening of Lizbe's, the actual compounds are all finished. We're just running a few side tests to just try and confirm if they were binding where we expected them to. Dana's hasn't started. That's unfortunately, we've just moved labs, which has caused us to have to recheck all the equipment and everything, but that's all up and running. All the testing's done. So equipment's ready. Everything's now ready to run the testing.
Awesome. All right. So so does that mean that the Lizbe's fragments have been done? You got data on those, and then the next thing to do will be the Dana fragments? Yeah. All right. Awesome. Great. Okay. And then Laura, to continue crystallization.
So just a clarification. Sorry, excuse me. Just as a clarification. So the Lizbe fragments are the ones from the original Mur XChem screen?
They are not the ones we designed in Cape Town. That's
no, I understand. I know that's not happening yet. Anyway, but these are the ones I assume that from the Mur screen. The stuff that has been out, and like Chris and others have tried to do design on. It's those fragments, right?
I can't speak to who else has been working on them. I just know that they were targeted against Mur binding to a little side pocket, not any of the substrate binding pockets.
Right. Okay. Thanks a lot.
Answer yes. Yeah.
Thanks, Becca.
I mean, I guess if we are able to share the data, we can just confirm the identity.
Yeah.
As well. And then crystallization trials, Laura, I remember the last time you were involved in all of this. How's it going?
Yeah, so I'm gonna start with Mur E. I'm gonna do the fragment screening this Friday in the presence of magnesium to see if we can get hits that are more reproducible. For Mur D, that one, the crystals are not that reproducible, so I'm trying to get new conditions and start that. But the condition I was following up is not giving as many crystals as I wanted, so I'm continuing with that. But at least we have something going on Friday.
And what's it? Sorry, I've got Mur C written down in that thing. Is that just have I made a mistake there? You're doing Mur D, Mur E?
Mur E, yeah.
Yeah, so Mur C is not involved in that, right?
No.
Okay. All right. And again, the same question about the fragments.
Which isozyme?
Say again, sorry?
Which isozyme for Mur E?
Is the E. coli.
Thank you.
And again, so same question as Joe had. These are the same fragments, or are we testing the same compounds?
Library. It's the same library, but the first screen that was done wasn't done in the presence of magnesium. So I incorporating magnesium and see if that gives other type of hits and like more real hits that we can reproduce later on.
Okay.
So I'm confused again. Sorry, I keep bugging into this conversation. So which first screen? Okay, so there was an original screen that I think is a diversity library out of the diamond.
Yeah.
And then there was a second one, which was actually the compounds that Becca and I put together, the 600 compound library. So I assume this is the diamond diversity library.
Diamond one, yeah.
So it's the same one that produced the original set of fragments, the quote Lizbe K fragments.
Yeah. Yeah, it's the same one, yeah. But obviously the crystal system is different now.
All right. Lizbe, you're famous. You have a library named after you.
Glad to hear I've got a library named after me.
Normally, you have to be an ex-president of the US to have a library named after you. Come on, this is a big deal. So that's all the biology that's in Warwick. Does anyone have any follow-up questions about the stuff that's going on? Okay, all good. And then the next item was Joe, Chris, and Bart to pursue AZ compound shipment for crystallization trials. Is that finished now? Have I mistakenly included that in the actions?
No, is Bart still on? Bart, maybe you can address this because you even know what the status is on your end.
Yeah, so I forwarded to you to this group the last response I got from AZ, which was they did reach out to our legal to negotiate the MTA. I forget when that was, but maybe it was only a couple of weeks ago. And that's the last I've heard. So in order for them to, so it seems like they were willing to, to move forward. So that's good.
Okay, so we're in MTA territory.
Right.
Okay. All right, got it.
Yeah, I mean, this is all really significant. I mean, last time we went through this loop with AstraZeneca, it was an 18-month process.
Yeah, exactly. I don't know. Peter managed to get some compounds out of them pretty fast once. But,
so I suppose, I mean, no one's objecting, I don't think. It's somebody who's agreed to do it, and then it's been devolved to the legal team, and the legal team do what the legal team do, which is clock up hours and make money. And yeah, there does need to be a way through all of this. And even with our own institutions, it's the same thing. I think we really do need platform agreements, and part of what we ought to be doing is coming up with platform agreements within open source consortia that, before anyone even agrees to join, they run this through their team and get them to sign up to it. I don't know. It's too painful otherwise, isn't it?
It is.
Yeah.
I think that's a really good idea.
I don't want to point fingers, but I guess I will. So we're in a process of doing several different things with AstraZeneca at Northeastern. My experience with AstraZeneca, and of course I'm a little bit biased since I spent 15 years there, but it's basically not a matter of them slowing things down. Usually it's just a matter of, they have a legal agreement, and then it's really, the collaboration on the receiving end of who wants to get access to compounds for them to actually get the thing through and agree to, the terms and conditions of, AstraZeneca's legal agreement. And then how much of that you want to edit and change, then that gets into, really more of the issues. So it's, anyway, I just feel like usually it's not AstraZeneca that's holding things up. That's not my experience. It's much more on the receiving end and the legal end, so however you can engage with your own legal departments and try to encourage them about how much this is a national, international collaboration, and it's all for the good of humanity, and you can grease the wheels that way. That's how things will get moved forward, in my opinion.
Unfortunately, the risk is a range, a continuous range variable, but the outcome is binary. So any element of risk results in the one of needing a document. And even if the risk is low, a document's still needed, and it's the same amount of work as if the risk is high. That's the frustrating thing. So my argument's about the fact that in this case, there is a risk somewhere. I mean, there's a risk somewhere that one of the atomized compounds is, explosive, right? And we ship it and someone gets injured, and then UCL is liable, right? There's a risk of that. It turns out the risk is several places away from the decimal point, but it doesn't matter, right? It's still a risk. And so the documents need it. And that's the same amount of time it takes as if the risk was very high. That's the frustrating thing. There's no nano MTA, it's either MTA or it isn't.
Yeah, I agree, Joe. I mean, AZ sent the agreement to Warwick 5th of the 3rd. And I agree, our legal team is notoriously risk averse. I tried to short circuit it by going through our venture capital group, and they weren't going to touch it. I'm going to.
Yeah, I agree, and I don't have our legal department is also quite risk averse and unlikely to have any incentive to do anything on this. So it's sort of like a toss up as far as I know. I wish that they would at least tell us if they had compounds, because they're not going to ship them if they don't have them. Like, they're not going to make them.
That's already cleared, Bart.
Oh, is it?
They had the compounds. Yeah, we went through this whole process with Pam and Kelly. I mean, they had the compounds. That's not the issue. We went through the list. We sent them a request, and they checked their inventory, and they have the compounds. So that's not the issue. Really, okay. It's in our court. If this is going to happen, it has to happen on our end. And so, I don't understand. At some level, I just don't understand this risk about things exploding. That's seems kind of bizarre.
I'm sure that's not going to happen. All right. I think the idea of a shared project agreement that we sort out in advance is a nice one. Still requires a document and some sharing of documents, but it would at least cover everything, which is a nice idea. Maybe next time or in the near future we could try that. Okay, the next item was that me and you, Chris, were investigating the Anthrop funding. So I'm still intending to apply for that. And I'm just going to need your inputs and ideally inputs from other people here for proofreading, for applying for about 50K's worth of consumables and other stuff for various labs who are here. That's the idea. So, no people funding, but stuff to keep the lights on. It looks like a pretty short application. And so I think we should be able to put something in by the end of the month, but it's the end of the month. So I just need a little bit of bandwidth from everybody to maybe help move that along. More on that ASAP. I was hoping I was drafted today, but I've got roped into some big EU proposal in the last few days, and I've had no time for anything else.
Matt, what I can do, if I haven't already sent it to you, is the now successfully funded Warwick Wellcome translational application
That'd be great.
For the Mur Ligase. So that's quite short and probably has a lot of cut and paste stuff in there.
Great.
Yeah, because I as a trustee, I can't go anywhere near the application.
Right. Okay. Sure.
But I can feed you information that will help.
Right.
Input to it.
Okay, great. And what I'd like to do is try and get some funding from that pot for everybody who could use it. I mean, that's the idea, just to sort of get 50K of money for helping move things along. That's all.
Just say, just be very. I was going to say, just be very directed in your application, because I know the people reviewing it, they're going to be wanting to see what you're going to do with it, rather than, a loose pot of money to be used. Sure. I know what the chairman will say.
Useful to know. Okay, great. Jan Jensen isn't with us, but I'll leave that item with him. He's going to be looking at some of the literature that we've got to try to be more predictive about the molecules you might want to make. Peter's with us, work on crystallization of Mur-C with enamine compounds sent by Jack. Any updates?
Yeah, I have a slide I can share if you want. I just
Okay.
need you to let me share. So I hope you can see it. Can you see my slide?
Yeah.
Yep.
Great. So we received the compounds from Lori and Joe. They were very kind and they gave us the priorities. And so we have crystallization going on for both Acinetobacter as well as the Pseudomonas, Mur-Cs and Mur-Ds. Acinetobacter has not produced any diffracting crystals, but the Pseudomonas has. We reproduced our previous crystals. We got some little better looking ones also. You can see it here. They are kind of small, but we'll sort of optimize them. But they're big enough for synchrotron, and so we soaked them with the compounds, the 4 that are here. These are the priorities that we received. And then we got some crystals from Mur-D, the Pseudomonas one. They look pretty, and they diffract about 3 angstroms in-house. We'll send those to synchrotron also. We couldn't find a APO Mur-D structure, so we figured that may be of interest. So it would also may be useful for us to sort of just know how well the crystals diffract without the compounds being present. So we'll also take a crack at that. We'll have some data, hopefully the 22nd is when we're anticipating it. So this was thanks to Bart sending us the protein, and as I mentioned, Lori and Joe sharing both the compounds as well as the priorities, and then the SMILES and all the necessary information that was important for us to log them and then get them into the pipeline. My comment for the MTA that Bart alluded to was that we didn't go through AstraZeneca, we went through Entasis. And so they were the people who actually was important to them, and that all of a sudden made it important inside. I think that both sides having people sort of making the priority makes it the paperwork go a lot faster. So that's my recommendation, is find someone that cares and then get them to be your advocate internally.
So Peter, so along those lines then, so again, it's great that Entasis, I know those folks, I work with them, but so someone I assume, was that with UCB or was that with
it was at SSGCID. So we were CRO
so who was
prior
the person
to me.
So who was the person at SSGCID that we need to get back in touch with?
No, so SSGCID, it was so we were beryllium CRO, and we had an ongoing work with Entasis. And we reached out to Entasis, who had Thomas Duran-Reville,
right,
who just made some phone calls and the compounds just appeared. And so I'm just saying that to me, if you have the right people.
MTA, so there was no MTA for that then, is what you're saying?
Well, there was an already existing MTA with beryllium.
Ah, got you. Okay.
Because they had CRO work already with us. And so I'm just saying that, if you have the right advocates and the right people sort of making the right phone calls, I think it's a lot easier on both sides. And we were part of SSGC at the time, so I think that that's sort of how we got the information, everything sort of taken care of. We were a small CRO, so our name of the game was to get the CDA put in place in a day or two.
Pro MTA tips there. Thanks.
Yep.
Great progress, Peter. Thanks, and Bart. That's very exciting. just for the rest of the team, and these are selections I kind of made by docking. They're small, relatively small, kind of using the same hinge, well, sorry, not hinge binding, but the same binding to asparagine that ATP binds to. We don't have biological data on those compounds, so we don't, this is a little bit of a crapshoot. But I think the great thing is hopefully there'll be some structures, but also the fact that Peter has got, these, crystal systems set up that will hopefully, if we don't have anything, maybe we can think about other compounds that if Peter is still willing to help out with, going down the road.
Sure.
So it's fantastic. Thank you so much. Really appreciate it.
Sure thing. Yeah, just let me know what compounds you want, and then funnel them to us through Bart, and we'll be happy to set them up. The more now that we have the crystal system set up, I think that the more likely that they bind, the more likely we'll get you information on them. But if the magic number of solubility is the affinity, that's usually it's a lot tougher.
So Peter, are you guys doing this in Bainbridge or in Boston?
Bainbridge.
Okay.
Everything's the same, Bart. It's just everything runs the same as when you were here. It's just different branding, different locations, but overall the same shops, same people, and we have a little bit improved imaging, as you can tell.
Yeah, it was nice.
Yep. There's like a scale bar for them and everything.
I know, I saw that. Is the scale bar correct? That's
it is. It's if you want, we can measure it for you. We can put a.
I'm looking at the Z codes there. I'm wondering what the structures are, and by chance, the next action item is on you, Joe, to post the structures of those compounds.
I can send you the file that Joe and Lori sent to me.
Lori posted it it's on the GitHub.
Oh, I'm sorry. Did I miss that? Okay.
It's on GitHub. If you go back to last month's
sorry.
notes,
Great.
All the structures are there.
Fantastic. Thanks. Okay, I'll look. I'm interested to know whether or not those compounds that you listed are structurally related, or if you've got structurally diverse compounds.
They're diverse as far as I can tell. They're not identical.
All right.
But they're similar but not identical.
Cool. Great. All right. Fantastic. Next thing was crystal liaise with others to establish protein needs and what's needed from SSGCID. I'm not sure if that took place, Chris. Did it? We were going to get together to think about resources.
Yeah, no, it didn't actually, but it's great that there's some brilliant progress with Pseudomonas and hopefully Acinetobacter. So yeah, it's really just filling up the matrix as to what else we could do with it. As we start to make progress. We just need to keep cross-checking, don't we? So I'll go back. I'll have a chat with Laura and then get back to you, Matt, and I'll have a chat to Joe as well. And anyone else who feels they would like to send me a mail.
Yeah, that would be great. We're kind of short in the SSGCID pipeline. If you wanted to do a whole bunch of Mur C, D, and E proteins from different organisms, that would be timely for us to get done.
Yes, book them in. We'll within 48 hours we'll have got a decision. Okay. So, yeah, okay, let's do that for the end of the week.
Sorry. Can I make a suggestion? So Laura, now that, and I don't know if Peter's up for this, but I guess it's a conversation between Peter and Laura, but we do have 600 compounds sitting from enamine sitting somewhere. I don't know if they're in Warwick or Diamond. I guess there should be some at Diamond. So Peter, I don't assume you don't really have like the XChem facility. You're kind of doing more we call it serial or small parallel, small numbers, not really what Diamond has with XChem, where they can do hundreds of crystals. So I'm just wondering at some point if it makes sense to, if we could, or if it was possible to transfer some of the Pseudomonas technology to the Diamond, and then can we revisit the enamine 600 compound library in an XChem screen? Because it was done against Mur E, and I think we kind of was, which is fine, the original 600 XChem screen, but a lot of stuff was really kind of done against Mur C in terms of the compound selection. So it'd be really nice if we could run that library against Pseudomonas Mur C in a kind of XChem format. Because I assume you don't really have the capacity to do 600 compound library.
Now we can definitely help in the process of either transferring Mur C or the other part. I just have a couple of questions to you. Are the compounds individual or are they pooled like in a smart pool?
No, they're individual. They're individual.
Can we make them into a smart pool so you can pool like 5 or 6 of them that are structurally distinct? So if we were to get one partially bound, we could actually figure out what's going on.
Lizbe? I guess that was a matter of restamping the plate. I guess I don't know how much. I can't remember how many microliters we got of the compounds. That's the other issue, is how many microliters are actually on the plates. I just don't remember.
Yep. I mean, we've done crystallography. Yep.
Sorry, go ahead.
We've done crystallography-based screening. It's. I don't think that we're adverse or we're against doing that. I think that we're just sort of. We're definitely not looking to screen 600 individual, crystals with different compounds, because I think that would be just the time. I'm not sure if I would need SSGCID brass to sort of approve that kind of time investment. But overall,
I think that they're going to do all that.
Yeah, but I'm just saying, if you were to do the pooling the right way, it would be like 50 or 60 pools. I think that would be a lot more feasible.
I mean, Liz was chatting because she doesn't have a microphone, but she says they're in an echo plate, so she can transfer them easily. Laura, were you coming in on that, or did you want to say something?
Yeah, I just wanted to say what Liz was saying. She's telling me also that she doesn't think it was his 100. She thinks it's a bit smaller than that. But anyway, it's in diamond, so I guess until if I have the crystals, then I can do that.
Yeah, we can help you with the setup of the crystallizations. That's not difficult. It's quite trivial. This is what you see here is from Morpheus or Morpheus 2. So there was no optimization done. Yeah.
I suppose the only other alternative would be to make the crystals that fit XChem parameters with resilience to PEG concentrations or DMSO concentrations, that reliably high diffracting crystals that you could then just clone that protocol and then just run it through an XChem screen over a weekend.
Yeah, maybe you can do the preliminary tests for the screening.
Yeah, it's really
just have to copy that,
isn't it? Do you have the kind of XChem crystal parameters? I mean, do you want to liaise, Laura?
Yeah, I can send them to Peter, and
just in case they match up to those already. In which case,
because it might be already in there.
Yeah. Thanks. I really appreciate the willingness to try this out.
Sure. It's a lot easier to transfer information than it is to transfer materials, from what I gather.
Yeah.
So, but on that, we everything that SSGCID does is freely available to the community. So there's also the possibility, like, we can just send you the plasmids, we can send you protein if we make it, stuff like that. Like, we don't, and there is an MTA involved, but it's a very basic electronic MTA that says you agree to make all your results, or you agree to publish everything and deposit everything in the protein data bank.
I'm just wondering, could we set up the open source project as a separate legal entity, and then we just sign off our own MTAs? How does that work? Can we get someone who's got a legal brain and work that out? Because that would do it. Yeah,
it's been a subject of conversation over the years about what kind of entity it could be, and I don't know how to do it, but I'm sure it's not that difficult. We'd need to form some sort of not-for-profit organization.
A charity, right?
Mm-hmm. Yeah.
In the UK parlance, I think they're called charities.
Mm-hmm. Mm-hmm. Yeah. Also paperwork involved in that, but it might save time eventually.
Okay.
No, it's a great idea. I just haven't got around to it. I know someone in UCL is interested in helping with it, and I just haven't connected with them. But we could do that for sure.
It sounds like the sort of thing that people like the Wellcome Trust and Co must have done many times.
Oh, they love legal contracts, the Wellcome do.
Mm.
And that was part of the problem with my little Wellcome grant for £47,000. It was all the legals.
Okay.
So they could get profit out of it. So I had to work out what bit they could have profit, and I decided it was the assay design and development. And they were happy with that. They would then keep away from any compound information.
You just have an issue about the fact that then, you then have an agreement with a charity organization, Open Source Antibiotics. And then the question is whether any of us are employees of that thing. And of course we're not, right? So you've got this MTA with OSA, but that doesn't actually help us because none of us work there.
Hmm.
So
Yeah.
I think it could simplify receiving money, but I'm not sure it simplifies follow-on paperwork.
Okay.
I'm sorry. I'm sorry. I can't keep quiet. But just back to this enamine library, 600 plus compounds. Just so the team knows, this was funded by a grant that Frank von Delft had, and we spent over 16,000 pounds for that library. So we should we should use it. And so we get some value out of that money that was spent out of Frank's lab.
Yeah, totally. I guess when you were talking about mixing them, that made a lot of sense in terms of keeping down the number of experiments, but I guess that's a little irreversible, isn't it? So once you mix things, you're going to lose some of the advantage of having isolated compounds. Is that an issue, or can you just mix small amounts of the samples that we have? Joe, do you remember how much you got of each compound?
I don't. I mean, I'm sure I can find out the purchase order somewhere and let the team know. I just don't have it on top of my head.
I mean, if you can take some of it and mix it and reduce the number of soaks you do, that might be sensible, right? But you just can't separate them back out again.
Personal view is keep them separate. Get crystals that will go through XChem, run through XChem. We can run the individual ones through the assays. Just have to hold on another 2 or 3 weeks for us.
Lizbe's pulling up the plate map. She's going to email it around.
Yeah,
I agree with Chris. I mean, I appreciate Peter's efforts. The idea of pooling and so on. But I mean, the XChem just has this amazing technology, and so I think that makes the most sense to do individual compounds, assuming you can get an XChem compatible set of crystals.
Mm. Okay, great. Just a couple of other small things. So Chris D and I had an initial conversation with AlphaFold, and we are following that up with some specific suggestions as to what to do, and exploring whether they could help with the project, but there's no commitment yet. We were thinking a little bit about the idea of trying to get structures in that kind of matrix of all the Murs versus the organism where they come from, to try and plug some holes there in the way that we were just talking about a second ago. But Chris and I need to have a follow-up conversation and try and come up with something, and then we'll pass it by the group just to try and follow up.
I think Laura's made some suggestions, haven't you, Laura? So basically, for each for Mur C, D, and E, a known structure and an unknown structure.
I think we have to. It might be a good idea just to pass that by people and then send it through. I think we have to have a small targeted request for them to have a go at. That would be useful to us, of course. So that's on us, I guess, Chris, to follow up. And then I'm not sure this is a really an official action for you, Bart, but you were thinking about maybe liaising with the David Baker lab about potential similar protein structure prediction work. Is that something you want to do, or should I take that off?
I apologize, I didn't do that. We do have a connection that we run our structures through the David Baker lab, the IPD protein prediction pipeline. I don't think it's their latest CASP. I don't think it's like their highest IP one, but our pipeline is connected to that. We just need to sort of push things that way. And I didn't talk to Isabel, who's in charge of that. So I'll have to do that.
Okay.
But that same list from Laura would be great to know what targets you're interested in.
Yeah, we could combine those, right? Yeah. Okay, and then the other thing I was going to mention was Chris Swain alerted us to the call from the European lead factory, call for proposals where we could ask them to do a screen versus one of the Mur enzymes. Deadline is May 28th, and we'd have to fill in something. By then, it seems like a win-win, apart from the fact we have to put in an application, but it seems like a win-win. Does anyone think that's not worth doing? I mean, that would be a big scale screen. I'm guessing that the proposal would be mostly on the assay. So we'd be presumably needing to justify the idea that they could run an assay for us, right? So it will be mostly technical biology in the proposal, unless I'm misunderstanding what it is they're doing. But they will be running a screen for us of a bunch of compounds, right?
Yeah, I mean, it's 500,000 compounds now, so it's a fairly sizable screen.
Right, and they would need to run that assay. It's not as if we run, they would run it and replicate it, right?
They would do all of that. They would do the initial screen. They would then do the confirmation screen. And if you have a orthogonal screen for something else, they will run that as well.
Okay, so unless anyone really wants to do this, I can do it. I'm just going to need inputs from everyone between now and May 28th. That's all.
So I guess the big question here is, is protein and substrate availability, right? So you have to provide that. I mean, so this is all falls on Chris Dawson's lab. And so, do you have, if you work out how much material do you actually need in terms of like substrates? Because I thought that was an issue you were having a little bit of, just generating substrates, or it's just a matter you can do it. It's just a matter of getting in the lab and making them.
Yeah, it was the fact that we've been in lockdown and a whole lot of reagents simultaneously had all degraded by about 20%, and then together, the reaction doesn't turn over in the right direction. Right. I mean, historically we've made, tens of hundreds of milligrams of reagents in every period of a week or two or three, and we've run a 60,000 compound Mur C screen with MRCT 12 years ago. So we've got 12 years more of experience, and we've gone through a Mur high throughput screen once before with a kinase focused library. I have to say, got nothing out of it. So got nothing out of it. That's why even 500,000, it's what goes into it, and and everyone has screened, this, Joe. How different is this library going to be to the one that AstraZeneca will have screened 20 years ago, or Merck 20 years ago, or Pfizer 20 years ago? I'm not sure. And the key is in the chemistry, isn't it? You know that more than anyone.
It'd be interesting to see what those AstraZeneca compounds look like in that screen, if they could include that compound, not the final one, but the initial hit, the warhead. See if there's anything better than that, or they can displace it.
Yeah. For me, the pitch to Europe would be, you need to, be rational and expansive. So just do what Joe did, and it's, designing not 60 compounds, 600, but 6,000 or 6, and do it in a more focused manner, really. So it's not necessarily a 200,000 or 300,000 compound screen.
I think the thing is, though, the European lead factory, for reasons of efficiency, they have one model, which is to screen the whole deck.
Yeah.
Will we know if the permeability of the compounds into cells?
No.
No, this is a biochemical screen, not a.
No, I understand.
Screen. Oh, I'm sorry.
No, I understand, but I'm just saying that. No, I mean, I understand that, but I'm just saying that, like, to me, that would be sort of. Those are some of the aspects that are sort of key for the compound to work, because there are two membranes we need to be able to get through to get the compounds to work. So right. Identifying 500,000 hits that don't penetrate the cell. I mean, how closer are we to the solution?
Is there a counter screen that you can run that will show you that? Because that could be your counter screen.
Yeah, I mean, the compounds are going to change some. I mean, you're probably not hitting a home run. You're not hitting a nanomolar compound out of this screen, most likely. I mean, awesome if you did, but it's very unlikely. And so then the fact that you would actually get, because eventually you're gonna have to change the molecule substantially to get the potency from the original hit, and then you're changing a whole bunch of physical chemical properties. And so any counter screen of the compounds from the library, I'm not sure how informative that would actually be, given how much change would end up having, probably most likely happen to the compound. But
makes sense. I mean, there'll be initial hits. I was just wondering, what level of screening will they do beyond just the biochemical?
Yeah, I wonder if they've done previously done a biochemical screen against a bacterial target, and may have already considered this. They may have already clustered.
Well, the original. I mean, everything Chris Schofield's been doing in what's called Enable, I think, came out of the ELF.
Oh yeah,
I recall.
Yep. Yeah.
That's interesting. All right. I mean, of course, we put the proposal in and they consider it. So these issues might come up. If the proposal is seen as being favorable, it might then be refined. I mean, Chris D, are you not keen on this period, or do you think there's value?
No, I think you have to try everything, don't you? You just have to exhaust everything.
Mm. I mean, my assumption is there are compounds there that are unique.
Well, just to give you a bit of background, about half the library were tranches of 50,000 compounds, which were donated by 6 pharma companies who formed the original consortium. The other half of the library is de novo synthesis, so they are new compounds that have never been made before.
Yeah. Yeah. Okay.
I'm just thinking about a conversation with Chris Schofield might be handy. He's having successfully gone through that loop. Happy to hook that in, really.
Are you happy to reach out to him?
Yeah.
Just loop a few of us in, because that would be very useful to know if there's some way of improving the efficiency of the screen for a bacterial target. That'd be great.
So Chris D, because we work with Chris S, so we have to call it Chris S and Chris D. But anyway, Chris D, what about the other binding site instead of the ATP site, the peptidic glycan, whatever the other
peptide binding, yeah.
So is that something that your assay would? Is there an assay for that? I mean, I'm just wondering if that would be another more novel or another option to consider.
I'll have a chat to Adrian to see how far he got on that. Yeah, let me check with Adrian where he's got to on that.
Okay.
All right, that's great. Thanks, everybody. Thanks, Chris S, for noticing that. This could be really useful. All right, that's everything I had. Did we not talk about anything? Anyone want to raise anything? I think we're all good.
Yeah.
Action item on me for the ELF is to send the legal document to my legal office. That's the first step. What do you know?
Yeah, I've had a response from my team, and it's been pushed up the chain. So, person with it has had a bit of a push.
Great. All right. Okay, fantastic. I'll send through. I've suggested another catch up, because there's lots of stuff going on at the moment. I'll suggest another catch up in on, when is it? 8th of June, Tuesday, 8th of June. It's nearly a month away. Assuming that's okay, I'll send through an invite ASAP. Very nice to see everybody.
All right. Thanks.
Okay.
Thanks,
All right.
everybody.
Great. Talk again soon.
Bye.
All right.
Bye.
Bye.
Bye, everyone.